Welcome to Cambridge IGCSE Physics, Lesson 50.1, Transformer Construction. Today we explore how transformers are built and their essential components. Transformers are fundamental devices in electrical engineering, used worldwide for voltage transformation in power systems. This lesson covers core content for your Cambridge IGCSE Physics examination, focusing on the basic construction principles that every physics student must understand. Let's examine our learning objectives for today. By the end of this lesson, you'll be able to, first, describe construction of simple transformer including all major components and their arrangement. Second, know has soft iron core, understanding why this specific material is essential. Third, understand used for voltage transformations, recognizing the practical applications. These objectives align with Assessment Objective 1, testing your scientific knowledge and vocabulary, and Assessment Objective 2, requiring application of concepts to solve problems. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, transformer, which means a device that changes voltage levels using electromagnetic induction. Second, iron core, which means the soft iron center that links the coils and concentrates magnetic field lines. Third, primary coil, which means the input coil that receives alternating current from the power source. Fourth, secondary coil, which means the output coil that produces the transformed voltage. Understanding these terms precisely is crucial for exam success and practical applications. Let's explore transformer construction. The fundamental principle states that every transformer contains 4 essential components arranged in a specific way. The construction involves 2 coils wound around a soft iron core. First, the primary coil connects to the alternating current supply, receiving electrical energy. Second, the secondary coil connects to the load circuit, delivering transformed energy. Third, the soft iron core links both coils, providing a path for magnetic field lines. Fourth, there is no electrical connection between coils. Energy transfers through electromagnetic induction. The diagram illustrates this arrangement clearly. Notice how the coils surround the iron core, and the connections show input and output terminals. This construction is fundamental because it enables voltage transformation without direct electrical contact. Now we examine why soft iron is essential for the core. This follows Cambridge IGCSE requirements for understanding material properties. Soft iron has specific magnetic properties needed for efficient operation. First, high magnetic permeability concentrates magnetic field lines within the core, increasing efficiency. Second, easy magnetization and demagnetization allows the magnetic field to change rapidly with alternating current. Third, low energy losses during operation prevent heating and improve efficiency. Fourth, it links the magnetic field between primary and secondary coils effectively. The diagram shows magnetic field lines concentrated within the iron core, flowing from primary to secondary coil. Notice how the field lines follow the iron path, creating strong magnetic coupling between the coils. Let's work through our first example. The problem states, a student examines a transformer and identifies 4 main components. Name these components and describe their functions. We are given a simple transformer with standard construction. We need to identify and describe 4 main components. Step 1. Primary coil. This receives alternating current input and creates a changing magnetic field in the iron core. Step 2. Secondary coil. This produces alternating current output, where voltage depends on the turns ratio compared to primary. Step 3. Soft iron core. This concentrates the magnetic field and links the coils efficiently for energy transfer. Step 4. Insulation. This prevents unwanted electrical contact between coils and core, ensuring safe operation. Example 2 explains how transformers change voltage levels. The problem asks us to explain the voltage transformation process. This uses electromagnetic induction, discovered by Michael Faraday. Now we analyze the 4-step process. First, alternating current flows in the primary coil. This current changes direction 50 times per second in most countries. Second, the changing current creates a changing magnetic field around the primary coil. Third, this magnetic field passes through the soft iron core to the secondary coil. The iron core concentrates and guides the field efficiently. Fourth, the changing magnetic field induces a voltage in the secondary coil. The result is voltage transformation without any electrical connection between input and output circuits. Mathematical skills are crucial in transformer analysis. The transformer equation relates voltages and number of turns in each coil. The basic relationship is secondary voltage divided by primary voltage equals secondary turns divided by primary turns. Where Vs represents secondary voltage measured in volts, Vp represents primary voltage in volts, Ns represents number of turns in secondary coil, and Np represents number of turns in primary coil. For rearrangement, to find secondary voltage, multiply primary voltage by the turns ratio. To find turns ratio, divide secondary voltage by primary voltage. Remember, this assumes an ideal transformer with no energy losses, which is approximately true for well-designed transformers. Now practice what you've learned with these three questions. Question 1 is basic level. It asks, name the four main components of a simple transformer. This tests your knowledge of transformer construction. Question 2 is intermediate. It states, explain why soft iron is used for the core rather than steel. This requires you to apply understanding of material properties. Question 3 is advanced. The question is, describe the complete process of voltage transformation in a transformer. This tests your analytical skills and understanding of electromagnetic induction. For all questions, remember to use correct scientific vocabulary, explain each step clearly, and demonstrate understanding of underlying physics principles. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how transformer construction applies in practice. In power distribution, step-up transformers increase voltage for efficient long-distance transmission, while step-down transformers reduce voltage for safe household use. The same construction principles apply at all scales. In electronics, phone chargers and laptop adapters contain small transformers that convert mains voltage to safe levels for devices. The soft iron core and coil arrangement remain the same. For safety applications, isolation transformers use the same construction but provide electrical isolation between input and output, preventing shock hazards. These applications show why understanding transformer construction matters. Career-wise, this knowledge leads to electrical engineering, power systems design, and electronics development. Globally, transformers enable efficient electricity distribution, making modern life possible. Let's review the solutions. For question 1, the four main components are primary coil, secondary coil, soft iron core, and insulation. Each component is essential for proper operation. For question 2, soft iron is used because it has high magnetic permeability to concentrate field lines, easy magnetization and demagnetization for AC operation, and low energy losses for efficiency. Steel would retain magnetism and cause losses. For question 3, the process is alternating current in primary coil creates changing magnetic field. Field passes through soft iron core, changing field induces voltage in secondary coil through electromagnetic induction. Now, exam success tips. First, use correct terminology consistently. Say primary coil and secondary coil, not just coils. Second, explain functions, don't just name components. Third, mention electromagnetic induction when discussing voltage transformation. Fourth, draw clear, labeled diagrams when questions ask for them. Let's summarize today's lesson on transformer construction. The key points to remember are, first, construction involves two coils wound around a soft iron core with no electrical connection between input and output circuits. This arrangement enables energy transfer through electromagnetic induction. Second, the soft iron core has high magnetic permeability, which concentrates magnetic field lines and provides efficient coupling between primary and secondary coils. Third, the function is voltage transformation through electromagnetic induction, where changing current in the primary creates changing magnetic field that induces voltage in the secondary. For further study, review the transformer equation and practice calculations with turns ratios. Practice drawing clear, labeled diagrams showing all components. The next lesson covers transformer efficiency, which builds on today's construction knowledge by examining energy losses and practical limitations.